What if time travel wasn't just science fiction? For years, experts have dismissed the idea as impossible. But what if they were wrong? Recent breakthroughs in quantum physics and relativity suggest that bending time might not be as far-fetched as we once believed. From wormholes to time dilation, scientists are uncovering clues that could change everything we know about the past, present, and future. Could time travel actually be possible? Let's dive into the mind-bending science behind it. Today, we will talk about why this fact about time travel might not be as impossible as you think. So before we get started, make sure to hit that like button. Also subscribe to my channel. Time travel has long been a fascinating concept that captivates scientists, philosophers, and science fiction lovers alike. From H.G. Wells' The Time Machine to modern-day blockbusters like Interstellar, the idea of traveling through time has intrigued humanity for centuries. But what if time travel isn't just a fictional fantasy? What if there are actual scientific theories suggesting that traveling through time, whether to the past or future, might be possible? While we may not have built a working time machine yet, there are theories rooted in physics that challenge the notion that time travel is completely impossible. Let's explore why time travel might be more than just a dream, and what scientific principles suggest it could one day become a reality. The nature of time. Is it linear or flexible? To understand time travel, we first need to understand time itself. Most people perceive time as a constant, linear force, always moving forward, never backward. However, modern physics tells a different story. According to Einstein's theory of relativity, time is not a fixed entity, but a dimension that is interwoven with space. This concept, known as space-time, suggests that time can be stretched, compressed, and even manipulated under the right conditions. Time is not an unchangeable river, but more like a vast landscape that can be traversed in different ways under specific circumstances. Einstein's theory introduced the idea that time is relative. It can speed up or slow down depending on the observer's motion and gravitational field. This is known as time dilation, and it has been experimentally proven using high-speed particle accelerators and atomic clocks aboard fast-moving spacecraft. This means that under certain conditions, time travel, at least to the future, is not only theoretically possible, but has already been observed on a small scale. Time dilation. A one-way ticket to the future. One of the most well-documented phenomena related to time travel is time dilation, which occurs when an object moves at speeds close to the speed of light, or experiences intense gravitational forces. This effect has been demonstrated in experiments where astronauts aboard the International Space Station, ISS, age slightly slower than people on Earth, due to their high-speed orbit. While the difference is minuscule, it proves that time can be experienced at different rates. The faster an object moves, the slower time passes for it relative to a stationary observer. This means that if a spaceship were to travel at near-light speeds for several years and then return to Earth, its passengers would have aged much less than the people they left behind. In essence, they would have traveled into the future. If we could one day develop spacecraft that can travel at a significant fraction of the speed of light, we could send humans thousands of years into the future, while only experiencing a few years themselves. While this doesn't allow for travel to the past, it demonstrates that time travel, at least in one direction, is scientifically possible. Wormholes, cosmic shortcuts. Through time? While time dilation allows for travel to the future, the idea of traveling to the past is far more complex. However, one potential solution comes from the concept of wormholes, hypothetical tunnels in space-time that could connect two distant points in time and space. These theoretical structures, sometimes called Einstein-Rosen bridges, could provide a shortcut between 2 points in the universe, making time travel possible. Wormholes are predicted by Einstein's general theory of relativity. But as of now, there is no experimental evidence to confirm their existence. Even if they do exist, they are likely to be highly unstable, requiring exotic forms of energy to keep them open. Some physicists believe that if we could stabilize a wormhole and manipulate its entrance and exit points properly, it could theoretically allow someone to step into one end and emerge in a different time period. While this remains purely theoretical, it shows that time travel is not completely outside the realm of time travel paradoxes. One of the biggest challenges in traveling to the past is the problem of paradoxes. The most famous of these is the grandfather paradox, which questions what would happen if a time traveler were to go back in time and prevent their own grandfather from meeting their grandmother. If they succeeded, the time traveler would never have been born. So how could they have traveled back in time in the first place? These types of paradoxes suggest that time travel to the past could lead to logical contradictions. Some scientists propose that the universe might prevent these paradoxes through self-consistency, meaning that any actions taken by a time traveler would always be part of history, preventing contradictions from occurring. Others suggest the existence of multiple timelines or parallel universes, where changing the past would simply create a new timeline rather than alter the existing one. Quantum mechanics and the possibility of time loops. While relativity suggests that time travel is difficult but not impossible, quantum mechanics provides some of the most intriguing possibilities for time travel. Some interpretations of quantum theory suggest that particles can exist in multiple states at once, leading to the possibility of quantum superposition and entanglement. This has led some physicists to speculate that time loops, or closed time-like curves, CTCs, might be possible at the quantum level. Experiments with quantum particles have shown strange behaviors that hint at time-related anomalies, such as particles appearing to influence their past states. While these effects are far from allowing a human to step into a time machine, they suggest that time might be more flexible than we currently understand. Could humans ever time travel? While the theoretical framework for time travel exists, making it a reality is another challenge altogether. The energy requirements for bending space-time or keeping a wormhole open would be astronomical, far beyond what our current technology can achieve. However, scientific progress has always pushed the boundaries of what was once thought impossible. Concepts like flight, space travel, and quantum mechanics were once deemed outlandish, yet they are now fundamental to our world. Some scientists believe that if advanced civilizations exist elsewhere in the universe, they might have already mastered time travel. If that's the case, then perhaps one day, humanity will uncover the secrets of temporal navigation. Until then, our best bet at experiencing time travel is to explore the universe at near-light speeds, or study the effects of time dilation on a larger scale. Time travel might not be as impossible as we once believed. While it remains beyond our technological reach for now, the laws of physics suggest that it is not entirely out of the question. The concept of time dilation, the potential of wormholes, and the mysteries of quantum mechanics all point toward the possibility that time might be more malleable than we currently understand. As science advances, new discoveries could bring us closer to unraveling the secrets of time itself. Whether through theoretical physics, quantum experiments, or space exploration, the future of time travel remains an open question, one that continues to inspire curiosity and wonder. What do you think of our video? Let me know in the comment section below. Before you go, please hit the like button and subscribe to my channel. Thanks for watching.